Okay, so now we're going to look at number 2. It says find the reference angle for the given angle. So we do have to be familiar with the location of these terminating angles. And in this case, we're looking at 155. That means we travel 90 degrees, not quite 180. So we're going to do 180 minus 155. So you get 5, borrow, you get 25. So 25 degrees from this horizontal is where we're going to be right here. Okay? So if I wrote this out, it would look like the following as far as the angle. It would go all the way right here. Okay, so from the center going out, this would be 155. And again, it almost reached that 180. And a reminder with reference angles, it's the angle measure between the terminating side and the nearest x-axis, which would be right here. And we're trying to find what would that angle be in a positive respect. And that's how you would get that 25 degrees. Okay, so now 5 pi over 3. Let's actually do C since we're going to be doing degrees both at the same time. So a negative 114, you could go negative 90 plus, so let's do 114 minus 90 to see how many more we would need. We would need an additional 24 degrees here, so 24 degrees extra with this 90 gave us 114. But again, the reference angles are saying from this terminating side to the nearest x-axis. So we're going to look at this. Please don't make the mistake of going to the nearest y-axis. We're looking from the nearest x-axis right here. So if this is 24, and we know this whole quadrant is taking up 90 degrees, you can by hand subtract. You get 6, borrow, you get 66. So 66 degrees, and again, these all are going to be positive with reference angles. Okay? Now let's go ahead and build our pi or our radians as far as what they will look like on the unit circle. Okay, so we have our circle, and it is a positive 5 pi over 3. So we know we're going to travel this direction. And our reference angle is hidden, or not hidden, it's shown right here in the radian measure given itself. So we know we're going to travel increments of pi over 3. So we know this is pi over 6, pi over 4, and this is pi over 3. So if I'm going to do 5 of these, I know that it takes 3 to get here to 180. Okay, so it took 1, 2, 3, and then we will go 4, 5. So again, it is the pi over 3 reference angle. So we know that there's going to be the 45, this 30, and this is like that 60. Kind of mirror image of quadrant 1. And this is what we're looking at right here. How far is this away from the nearest x-axis in terms of radians? So this will, of course, be pi over 3. And yes, with radians, it is a little bit easier because you can see that the reference angle, again, is right there. I just want to visually show you what this would look like as far as where it would travel, and just to prove that the answer is going to be pi over 4 anyway. We'll see here in just a bit. So we have pi over 4. So if I travel 1 pi over 4, it would be here. 2 pi over 4, 3 pi over 4, and 4 pi over 4 will of course get us to this pi. Now we just have to go 25 times. So 4, 5, 6, 7, 8. So you know one complete revolution is going to be 8 pi over 4s, because this would reduce it to 2 pi, which makes sense because one revolution is 2 pi. So if it takes 8 of these and I'm trying to travel 25, well then the second 8, 1, 2, 3, 4, 5, 6, 7, 16 would be the second 8. And then yes, we'd go 1, 2, 3, 4, 5, 6, 7, another 8 to get us to 24 pi over 4s, and then we would just have to travel one more, which would get us right here in quadrant 1, and again, to the nearest x-axis would be that reference triangle, or reference angle, which in this case is 45 degrees otherwise, in radian form, pi over 4.